So till now we have done with 12th question. Now I will continue with 13th question. So 13th question is two identical charged spheres of material density rho suspended from the same point by inextensible string. Right. So two strings are there and two identically charged spheres are there. So they will repel and they will repel each other and come to the end points, extreme points, correct? So here if you see two forces are there, QE one force and MG one force, and this tension is there. And this angle is given as theta, right? Make an angle theta between the strings. Okay, sorry. This is theta, angle between the strings. So angle, this angle will be theta by 2, correct? So now for this to be in equilibrium, net force due to this and this should be along this, right? So that it T and this gets cancelled, right? So if this is along T, then this will be also theta by 2. Then if you take here one triangle, what you will get? You will get it as this will be theta by 2 and this will be QE and this will be MG. So tan theta by 2 will be opposite by adjacent. Oh, sorry. This is not QE. This is KQ square by R square, correct? Where R is the distance between the centers. And this will be mg. So this will be tan theta by 2 will be, this will be kq square by r square. This is mg. So tan theta by 2 will be kq square by r square mg, correct? By mg. So this is tan theta by 2. Now they are telling it is suspended in a liquid of density rho. Sigma. So if it is put in a liquid of density sigma, then what will happen? They are telling angle theta remains same. Huh? So when we put inside a liquid, what else will come? One thing is this force changes because this k, which is 1 by 4 pi epsilon naught, it becomes 1 by 4 pi epsilon, where epsilon is k epsilon naught, where k is dielectric constant of liquid. And so this force will become, if I take dielectric constant as capital K, this quantity will become 1 by k into k q square by r square, correct? 1 by small k is 1 by 4 pi epsilon naught. This capital K is dielectric constant. So this horizontal force will become this much, and vertical force apart from T, vertical means if we exclude T, what other forces are there? One is mg in vertical direction, and one more force is there because of this liquid. That is Bernd force, which will be upwards, which will be equal to density of the liquid into volume displaced into g. And volume displaced you can get because we know mass and density of this ball, this charged sphere. So volume density is equal to mass by volume. So volume will be mass by density. So mass of the sphere by density of the sphere, that is rho. We'll see that. So now if you see in vertical direction, now mg is not the force. Mg minus rho vg is the mg minus sigma vg is the force. So this will become, we focus on the whole. This force will be mg minus sigma vg, and this force will be 1 by k into kq square by r square. And again they are telling theta remains same. So again if you take the resultant, this will be theta by 2. So tan theta by 2 here again will be, it will be 1 by k into kq square by r square by mg minus rho vg. So now this tan theta by 2, this tan theta by 2 are same. So if we equate both of them, what we will get? 1 by k and kq square by r square divided by mg minus sigma Vg is equal to kq square by r square by mg. So kq square by r square, kq square by r square is get cancelled. This V I can write as density is equal to mass by volume, volume is equal to mass by density. So I can write it as m by rho, density of the sphere. Then you see mg, here also mg is there. Now you take this here. What you will get? Mg by k is equal to mg minus sigma mg by rho. So mg cancels. What remains? 1 by capital K is equal to, we want capital K value, right? Is equal to 1 minus sigma by rho. So K will get as, this will be rho minus sigma by rho. So K will be rho by rho minus sigma. This is option A. Then 14th one, if you see, two equal and opposite charges of mass m1 and m2 are accelerated in an energy field to the same distance. What is the ratio of accelerations? So force on q, force on one charge will, one is plus q, one is minus q. So force on one will be qe, and another also will be of magnitude qe. So this force is there. Force is equal to mass into acceleration. Force is equal to mass into acceleration. So because forces are same, suppose this is m1 a1, this is m2 a2. So m1 a1 is equal to m2 a2. So by this we will get a1 by 2 as 2. So 14th one is option A. a1 by 2 is equal to 2. Then electron of mass m, charge E falls through a distance h material in uniform. So if there is electron, suppose it is falling, so the electric field is like this. So force on this will be like this, which will be of magnitude E into E. So this is force. They want time of fall. So how to get? They have given h also, the distance h and time t. So now this is uniform force, means constant force. So uniform acceleration motion it is. So we can use s equal to ut plus of at square. S is h, distance traveled, u is 0 because it is falling. So initial velocity is 0. Then we get half acceleration is force by mass into t square. So from here if we get t, you will get t as root of 2hm by e, correct? Then if you want to go further, next 16th one. So what is 16th? 16th is simple. You have direct formulas. E axial is E axial is 2 kp by 2 kp by r cube, and E is E axial, and E equatorial is minus kp by r cube, correct? Vectorial is correct. So if you see this, you will get option kp by r cube is there, so minus E. So here if you put minus E, it will be minus 2E equatorial. So which is option C. 16. Then 17th, an electric dipole is kept in non-uniform electric field, generally experiences. This is electric dipole, so plus Q minus Q, suppose. That is kept in non-uniform electric field. So here, suppose force is E, Q E1 here, because electric field is not constant everywhere, it is non-uniform, so different force may get applied. So this force and this force may not be same. So it will experience a net force. If you take this as one system, it will experience a net force. And it will experience a net torque also. So this will be clockwise. This will also be clockwise. So net torque will be clockwise. So it will have both force and torque. 17 is B. Then 18th problem. Now ray optics come. Ray optics starts from here. So in this 18th one we will discuss later. Just get back to it. 19th we will start. 18th and 21, and this I will solve later. For now, these two problems I will solve later. 19th we will start. So 19, what is the 19th problem? Image of an object approaching convex mirror of radius of curvature 20. This is a convex mirror. This is not concave mirror. This is convex mirror. Right? And its radius of curvature is how much? 20 meter. So if this is radius of curvature is 20, the center of curvature is there here, then focus will be 10. Correct? F is equal to R by 2. And F is positive. F is equal to plus 10. Right? Then observed is observed to move from 25 by 3 meter to 50 by 7 meter. So in convex lens always we get a virtual image, correct? You can think how, okay, you can use 1 by f is equal to 1 by v plus 1 by u mirror formula, and see u is always negative, so it will be minus of 1 by f is equal to 1 by v minus 1 by v minus 1 by mod u, and if you take mod u that side, then you get 1 by v is equal to 1 by f plus 1 by mod u, where f and mod u both are positive always. V should always be positive, which is this side. So the image will be always virtual this side. Then if you see, it is told that image is seen to move from 25 by 3 meter to 50 by 7 meter. So this will be your V1, this will be your V2, and positive only in 30 seconds. They are asking speed of object. So how to get its corresponding U1 and corresponding U2, and this change happens in 30 seconds. So distance traveled by the object will be difference between these two, and divided by time we will get speed. But they want in kilometer per hour, not in meter per second. So how to get? Use mirror formula, 1 by v, 1 by v plus 1 by u. So if you use, this will be 10, this will be 1 by v, right? So v1, so this will be 3 by 25 plus 1 by u1. Substitute this v1 here, right? You will get 25 by 3, which is 3 by 25. Then u1, 1 by u1 will be 1 by 10 minus 3 by 25, which will be 25 minus 30 minus 5 by 10 into 25. 5 ones are 5 5s are. You will get u1 as minus 50, correct? Meter. Then u2, if you do similarly, what you will get? 1 by 10 is equal to v, if you say, you will say 1 by 50 plus 1 by u2. So 1 by u2 is equal to 1 by 10 minus 7 by 50. 50 minus 70 minus 20 by 10 into 50. So answer 125 is so u2 is equal to minus 25. So if you see, they don't want towards the mirror or away from the mirror. So difference, if you see, it is 25 meter. So it is going 25 meter in 30 seconds. So this will be the speed, which is 5 by 6. But they don't want it in meter per second. They want in kilometer per hour. So to convert in kilometer per hour, 18 by 5. Sorry, it will be 18 by 5 kilometer per hour, which will be 5 I can say 1 is 3. So it will be 3 kilometer per hour. And 20th, if you see, 20th similar way, not similar, but a concave mirror is there here. So a concave mirror is there, which is a focal length 25 centimeter, forms a real image twice the size of the object. So real image is concave mirror is there whose real image is forming. So real image, if it forms, it will form here, right? And it will be inverted. Real inverted it will be. So what we'll get, if a image is twice the size of the object, m will be minus 2. Right? Focal length is given as 25, and if it is concave mirror, so minus 25. Right? This is equal to minus 25, and m is minus 2. This is initial m. Then screen is moved and away from the mirror, and object is also shifted, so that size of the image is thrice now that of object. So m2 will be minus 3. So for this to happen, we are asking what is the condition. Huh? So suppose v1 and u1, if you consider for mirror, m is equal to minus v by u. So this will be minus v1 by u1, which is minus 2. And for here, it will be minus 3, minus v by u. So this is cancels. This will be, so v1 will be 2u1 and v2 will be 3u2. So if you see, if you apply mirror formula, 1 by f is equal to 1 by v1 plus 1 by u1. So F is 25 minus 25, 1 by minus 25, 1 by V1 is 2U1, correct? 2U1 plus, so from here you will get U1, right? 1 by 2 plus 1 is 3 by 2, 3 by 2 U1. So U1 will be 75 by 2. So U1 you will get as minus 75 by 2, which is minus 37.5 centimeter. And U2 also similarly will get 1 by minus 25, 1 by F is equal to 1 by V2, that is 3U2 plus 1 by U2. So this will be 1 by 3 plus 1, that is 4 by 3 U2. So U2 will get as minus 100 by 3, which is minus 33.33, right? Minus 33.3, so centimeter. So if you see this diagram, so initially it was at U1 is minus 37.5. So initially it is at 37.5, right? And finally it is at 33.3. So it is coming towards the mirror. And how much it has come? 37.5 minus this is, and this is 2, 4, right? 4.2 centimeter towards the mirror, which is option. Is option A. Option A. So then 21st I will call later. Then 22nd. Yeah, 22nd is, this is fish inside water. So fish is there inside the water. So it is seeing object which is 24. So it is apparent depth formula. Hai na? So here it is coming from rarer to denser medium. So like this, rarer to denser towards the normal. So it will see above. So it will be apparent height is equal to real height into n, which is 24 into 4 by 3. 1 is 8 is 8 4 is 32. It will be 32 centimeter above the water surface. Then we have ray of light falling on glass. 23rd, ray of light falls on a glass plate of the fluorescent. The angle between the, okay, a glass plate is there, and a glass plate is there. It falls on the glass plate. Sorry, it falls on the glass plate. Light ray falls on the glass plate. So some part will get internally reflected, correct? Some part will get refracted. And it is going from rarer to denser towards the normal glass plate. So if this is I, asking angle, they are telling angle between reflected and refracted rays 90. So this is I, angle of incidence. They are asking angle of incidence only. If this is I, this will be also I is equal to R, and this is R. If you see this is 90 degrees, so I plus R should be 90 degrees because this full angle is 180. So I plus R is 90, so R is 90 minus I. So if you apply Snell's law now here, sin I by sin R is equal to N2 by N1. So what will you get? Sin I by sin R is 90 minus I is equal to N2 by N1 N. So this will be, this will be sin I by sin of 90 minus theta is cos theta. That is cos I is equal to N. So tan I is equal to N. So N I is equal to tan inverse of N. So that will be option D. 23 is option D. Then we have 24th. So what is 24th problem? So a small object is placed at a distance of 20 centimeter from a glass block of thickness 10 centimeter. So its thickness is 10 centimeter, and farther side is silvered, and the object is there here at 20 centimeter from the glass block. This is 20. This, so object is at distance of 20 centimeter from glass block. Its thickness, glass block thickness is 10 centimeter. Then this farther side means from the object it is farther. This is nearer. It is silvered. The image, this is nothing. The image is formed 23.2 centimeter behind the silver surface. So this is 23.2 centimeter behind the silver surface of the block. the refractive index of the glass is. So what is its refractive? So this is the image formed. So if you are standing here, if your eye is here, you will see the final image here. So now how to do? They are asking refractive index of a glass. So if you see for the glass, for the mirror, if you see, okay, before mirror, see the light ray from the object will come like this. Here if you see, it is going from rarer to denser. Rarer to denser, it bends towards the normal. So wait, I will draw this little bigger. Ah, uh, okay, no problem. So if you see, it goes from rarer to denser, which where it bends towards the normal. So there will be apparent shift, right? Where the image will form, where the light ray appears to come from a further point, and that distance will be 20 into n, correct? HR is equal to HA is equal to HA into HR into n. HA is equal to HR into n, right? Apparent height is equal to real height into n. So this will be 20n from here. So now for the mirror, it appears that the light ray is coming from here, that is 20n. So for the plane mirror, the image will also be formed at same distance. So for mirror image, object distance is 20n plus 10. So this from mirror, this will be at 20n plus 10, correct? So now from mirror again the light will reflect, but this light appears to be coming from 20n plus 10, right? But again it contracts this interface between glass and air, right? So again here it will bend denser to rarer away from the normal. So it will go away from the normal. So it appears that this image, which is formed by the mirror, the person, uh, the lighter before hitting the person's eye, it bends right here. So for the person, it appears that the light ray is coming from some nearer point compared to this image formed by the mirror. So for us, the final image will be at for this 20 n by 10. Okay. For this refracting surface, what is the distance? 20 n plus 10 plus 10. Correct? This plus 10, which is 20 plus 10, right? So this is the distance 2n plus 20n plus 20. This is the distance for this interface, this object. So this is the real depth for that. So now apparent depth will be seen by you. That will be the final image. So apparent depth will be real depth by n, correct? Because it is going from denser to rarer. So apparent depth will be, real depth is 20n plus 20 by n. This will be your apparent depth from the interface. But we know if from the interface it is 20n by 20n plus, from the interface final image is at 20n plus 20 by n. From mirror it will be okay. Okay. So this distance should also be equal to the outward final image is at 23.2 centimeter from the mirror. From interface it will be plus 10, which is 33.2, right? So now this is equal to 33.2. So now 20 plus 20 by n is equal to 33.2. So 20 by n is equal to, what we will get? 13.2. So n will be 20 by 13.2, which is, if you calculate, it will be 1.51, close to that. You can take it as 200 by 132, then solve it. You will get 100 by 66, 50 by 30, 50 by 33. 33 ones are 33. 1.51 will get. This will get. Then we will go for 25th. So 25th is a beam of light passing from here to the transparent medium suffers deviation of 15 degrees. So it is going from A to a transparent medium. So It is going from denser to rarer to denser only, because air is rarest next to vacuum. But so it is going from denser to rarer to denser. Sorry, rarer to denser. So rarer to denser towards the normal. So it was going like this undeviated path, but this is a deviated path. So how much it deviated, that is angle of deviation, and that is given to be 15 degree. And this angle of deviation you will get as I minus R, correct? Vertically opposite angles if you take I minus R. We have discussed this. So there again I as 60 minus R and D as 15 degree. So R will be 45 degree. So now apply Snell's law. Sin I by sin R is equal to N1. I is 60. R is 45. Is equal to N to N1. So N. So 60 sin 60 is root 3 by 2. Sin 45 is 1 by root 2. So root 2 and here root 2 will get. So N will be equal to root of 3 by 2. This is option A. So then what will get? 26th. A fish at a depth 10 meter in a pond can see the sky in a cone. So this is TIR problem, correct? Because you can see only light can only pass from this cone where I is equal to IC. A little greater than IC, it will not go. So this cone's semi vertical angle, sky in a semi vertical angle. Okay, they're asking this semi vertical angle only. So basically they're asking IC, right? This is vertical angle, this is semi vertical angle. So they are asking IC basically. So sin IC is equal to 1 by n. We know this, right? So n is 4 by 3. So this will be 3 by 4. So IC will be sin inverse of 3 by 4, which is option A. That is option A. Okay. So then we will go ahead. So 27, 28, 29, 30. So 27th, if you see, so there are two prisms. So one prism deviates it by 10. Sorry. Okay, second. So a thin glass prism is there of 10 degree, refract 27.5. It is combined with another glass prism of angle theta, and refract index 1.7. So if monochromatic ray passes, another is there, suppose like this prism. The monochromatic ray passes undeviated through the combination. So through this combination, it goes undeviated. So it goes like this undeviated. So when this can happen, and they are asking this theta. And when this can happen, deviation produced by this should be equal to deviation produced by this. Then there will be no deviation. Suppose this rotates by 30 degree and this also rotates by 30 degree again. So it is already rotated by 30 degree like this. Again you rotate it by 30 degree like this. So it will go in its undivided path only. So deviation due to this and due to this should be equal. And we know deviation formula is n2 1 minus 1 into a minimum deviation formula. So so for both of them, this should be same. Then there will be no deviation. So how to do? Refractive index for this is 1.5 minus 1 into A1. A1 is 10 degree is equal to N2 1 minus 1, that is 1.7 minus 1 into A2. A2 is theta. So 0.5 is 1 by, he will get 0.5 here into 10 into 0.7 into theta. So what will get? Theta as 0.5 into 10 by 0.7. So this answers 50 by 7 you will get. 50 by 7 is approximately 7, right? 49, 7, 7, 49. So it is approximately 7. 7. Okay. Then 28 is principal focus of an equiconvex lens is at a distance of 10 centimeter from the lens in air. When the lens is inside, the distance is okay. So basically they asking focal length, correct? So 1 by f is equal to n2 1 minus 1 into 1 by r1 minus 1 by r2. Lens makers formula. Initially it is 1.5 minus 1 into equiconvex, so 2 by r will get, correct? So here this will be 1 by 2.5. So f is equal to r, which is 10 centimeter given. Then when the lens is inside, this, right? So here is equal to n2 is 1.5, n1 is 1.25 minus 1, n2 2 by r is 10. So this will be 25 6 25 5 6 by 5 minus 1 is 1 by 5 into 2 by 10. So what will get? 2 1s are 2 5s are 5 5s are 25. So F will be 25. Option B. 28 is option B. Then we have 29th. The greatest thickness of plano convex lens appears to be 4 cm when observed through the plane surface. So plano convex lens like this, right? So when observed from the plane surface, so you are observing from here, and then lens appears to be 4 cm thick, correct? Greatest thickness. From here the thicknesses are there, but this is the greatest thickness. It appears to be 4 cm. So here you can use apparent depth formula, correct? From here he is seeing, suppose you have kept some coin here, so he is seeing this bottom. So from the bottom rays are coming, but they are getting refracted here. So it is going from denser to rarer, away from the normal. So apparent depth is equal to real depth by n. So apparent depth is 4, right? And 17 by 8 when observed through the curved surface. So when you observe from here, it will be 17 by 8. That is okay. If the real thickness of the lens is 6 centimeters, so real depth is 6, correct? If this is 6, then real depth is 6 by n. Then they are asking refractive index of material. So n they are asking, n is 3 by 2, right? 3 is a 2, which is option B. So 29th is option B. Then we have 30th, the last question. One of the faces of a prism of refracting angle 30 degrees is silvered, right? Is silvered. Okay, we have solved this actually. So one of that is silvered, and this is 30 degree. Light ray incident at a 45 degree, right? And it goes like this. So they are telling on the other side, retraces its path after refraction and reflection from the silver surface. So when this can happen, retracing, it is falling at the plane mirror at I is equal to 0, correct? At the normal, along the normal. So this should be 90 degree. I is equal to 0, R is equal to 0. Then only it can retrace. So refractive index of prism is how much? So if this is 90, this will be, so basically R2 is 0 here, if you see. So you can use A is equal to R1 plus R2, that also. Where R2 is 0, A is equal to R1. So R1 will be 30 degree. I is 45. So Snell's law if you use, you will get. Otherwise R1 if you have to get basically. So if this is 30, you can get like this also R1. This is 90, this is 30, this should be 60. And this is perpendicular, so this should be 60. Sorry, 30. This is 60, this should be 30. So R1 again you got as 30. Or by this also 30. So if you use Snell's law, you will get sin I by sin R. I is 45. R is the 30 degree is equal to n to n. So 1 by root 2 sin 45. Sin 30 is 1 by 2. So n is equal to this root 2 times n is equal to root 2. Option C. 30 is option C. Okay. So two problems are remaining, 18th one and 21st. I'll solve that in the class maybe. Okay. Any doubts you can ask later. Yeah. Thank you.